Today, we're taking you inside America's supergiant gold recycling plants, where mountains of e-waste are transformed into pure, gleaming gold. For most people, electronic waste or e-waste is just junk. But hidden inside these discarded gadgets is a fortune, tiny traces of gold. In fact, a single ton of old circuit boards contains more gold than a ton of ore mined from the earth. Before we dive into this mind-blowing process, don't forget to like, subscribe, and hit the notification bell so you never miss our deep dives into the hidden worlds of global industries. For decades, people threw away old radios, televisions, and the first computers without a second thought. Back in the 1960s and 70s, few realized that inside these machines, on their green printed circuit boards, lay traces of one of the world's most valuable metals, gold. At the time, these boards were simply considered electronic trash. It wasn't until the boom of personal computers and mobile phones in the 1980s and 90s that the hidden value began to attract attention. Millions of circuit boards were being discarded every year, and scientists started experimenting with ways to recover the precious gold hidden in their thin layers and connectors. Early methods were crude and dangerous, often involving toxic chemicals like cyanide or mercury. Still, the realization had been made: electronic waste could be richer than natural ore. By the 2000s, with the explosion of smartphones and the internet, mountains of e-waste were piling up worldwide. Governments in the US and Europe introduced new regulations pushing companies to recycle responsibly. High-tech plants were developed using shredding, smelting, and electrolysis to safely recover gold. For the first time, recycling gold from PCBs became an industrial process, not just an experimental idea. The journey begins in massive collection centers across the US. Old computers, servers, cell phones, televisions, and other devices pour in by the truckload. Workers and machines sort through this mountain of e-waste, separating plastics, steel casings, and valuable electronic components. The focus is on printed circuit boards, the green boards dotted with chips, capacitors, and connectors. These PCBs are the treasure maps of modern electronics, hiding tiny but valuable amounts of gold along their pathways and pins. In a supergiant recycling facility, conveyors carry thousands of pounds of boards every hour, feeding them into shredders that grind the boards into small fragments, making it easier to extract the precious metals. Once shredded, the e-waste fragments undergo a series of mechanical separations. Powerful magnets pull out steel. Eddy current separators remove aluminum and copper. What remains is a concentrate of plastics and precious metal-rich material. This material is then ground into fine powder, almost like dust. Why? Because the finer the material, the easier it is for chemical processes to access the metals trapped inside. At this stage, the powder still looks like waste, but within it are flecks of gold, silver, palladium, and other valuable metals waiting to be reclaimed. Now comes the most fascinating and delicate part: extracting pure gold using chemistry. Traditionally, gold is separated using harsh chemicals like cyanide or mercury, but modern American recycling plants employ safer, more sustainable techniques. One of the most common methods is aqua regia, a mixture of hydrochloric acid and nitric acid that dissolves gold into solution. Here's how it works. 1. The ground e-waste is mixed into giant chemical tanks. 2. As the solution works, base metals like copper dissolve first, leaving behind the precious metals. 3. Gold, being more resistant, requires special conditions to dissolve. Once it does, it exists in liquid form as chloroauric acid. before. To recover it, engineers add reducing agents that cause pure gold to precipitate back out of the solution as fine particles. These tiny particles are then filtered, washed, and dried, leaving behind a brownish gold powder known as gold precipitate. The precipitate is not yet the shiny gold you imagine. It must be refined. The powder is collected and melted in high-temperature furnaces, reaching over 1,100 degrees Celsius. As the powder liquefies, impurities rise to the surface and are skimmed away. What remains is 99.99% pure molten gold. Workers carefully pour this glowing liquid into molds, where it cools and solidifies into gold bars, coins, or granules. Each bar is stamped with its purity and weight, a mark of value recognized worldwide. It's astonishing to realize that this bar, worth tens of thousands of dollars, came not from a mine deep in the earth, but from old smartphones and computers that people once tossed away. Gold recycling is more than just profitable, it's vital for the planet. Extracting 1 ounce of gold through mining can produce over 20 tons of toxic waste rock. By contrast, recycling requires far less energy and reduces greenhouse gas emissions significantly. However, the process isn't without challenges. Handling e-waste involves toxic substances like lead, mercury, and brominated flame retardants, which must be carefully managed to avoid harming workers or the environment. That's why modern American facilities use advanced filtration systems, closed-loop chemical processes, and strict environmental standards to ensure safety and sustainability. Globally, only about 20% of e-waste is properly recycled, meaning that mountains of valuable materials are still being dumped or burned, releasing toxins into the environment. The US, however, is home to some of the largest and most advanced e-waste recycling plants in the world. These facilities not only recover gold, but also silver, platinum, copper, and rare earth metals, essential for building new electronics, renewable energy systems, and even electric vehicles. As demand for technology grows, the importance of this industry will only increase. In fact, experts predict that by 2030, the value of urban mining, recovering metals from waste, could surpass traditional mining in certain sectors. If you found this journey fascinating, make sure to like the video, subscribe to the channel, and hit the bell so you never miss another deep dive into the world's most mind-blowing industries. Thanks for watching, and remember, the next time you hold a smartphone in your hand, you're holding a little piece of gold. Today, we're taking you inside a supergiant recycling plant where mountains of discarded wood are collected, sorted, shredded, and pressed into particle board. A material that has quietly become the backbone of modern construction and furniture making. Before we dive into this fascinating journey, make sure to like, subscribe, and hit the bell icon so you won't miss more behind-the-scenes stories of how the world's most essential materials are recycled and transformed. The story of particle board begins during the early 20th century, a time when the world was searching for cheaper and more efficient building materials. In Germany, 1887, engineers first experimented with bonding small wood particles using natural adhesives. But it wasn't until the 1940s, during World War II, that particle board as we know it today truly took shape. With raw timber in short supply, German inventor Max Himmelheber patented a process in 1941 to create boards from wood chips and shavings, materials that were once considered waste. His invention opened the door to producing strong, affordable panels without relying solely on solid lumber. Today, the the world's largest particle board plants can recycle millions of tons of wood waste every year, turning what was once landfill material into durable boards used in homes, offices, and commercial spaces. Our journey begins with the arrival of truckloads of wood waste. Every single day, semi-trailers packed with discarded pallets, old furniture, shipping crates, and demolition waste pull up at the gates of this enormous plant. In the United States alone, more than 12 million tons of wood waste is generated each year. Instead of letting this wood pile up in landfills, plants like this give it a brand new purpose. Once the trucks unload, the wood is spread out in huge open yards. Here, workers and machines begin the process of sorting and grading. Clean wood, free of paints, chemicals, or glue, is separated from contaminated material. Nails, screws, and metal brackets are removed using giant magnets and metal detectors. The clean wood is stacked aside for the next stage, while unusable scraps are either burned for energy or disposed of safely. This careful preparation is critical, because particle board requires uniform, clean fibers to achieve strength and consistency. A single piece of contaminated wood could affect the entire production batch. After sorting, the wood moves into massive shredding machines. Picture enormous steel drums with razor-sharp rotating knives capable of chewing through wood at lightning speed. The shredders break the wood into chips and splinters, reducing bulky pallets and furniture into small, manageable pieces. These wood chips are then sent through another stage of grinding, where they're further reduced into tiny flakes and fibers. The goal here is consistency. Every fiber needs to be about the same size, so the final board has even density and no weak spots. Next comes drying. The wood fibers are sent through long, heated conveyor dryers. Here, powerful hot air removes excess moisture, reducing the content to about 2 to 5%. This step is crucial. Too much moisture would cause the board to swell and crack later. By the end of this stage, the plant has transformed thousands of tons of bulky wood waste into a fine, uniform raw material, ready to be turned into something new. Now comes the science that turns loose fibers into a solid board. The dried wood fibers are mixed with synthetic resins and adhesives. Inside huge blending drums, jets spray a mist of resin onto the falling fibers. The resin acts like glue, bonding the particles together when pressed. Some plants also add wax to improve moisture resistance. This mixture is carefully controlled. Too much resin makes the board brittle, too little makes it weak. Engineers constantly test samples to make sure the ratio is just right. Once mixed, the fibers resemble a soft, fluffy carpet. But the magic is about to happen. The resin-coated fibers are spread out evenly onto a moving conveyor belt, creating a thick mat of loose material. This mat can be several inches thick and many feet wide. From here, the mat passes through a giant hot press, one of the most impressive machines in the entire factory. Under intense heat, up to 400 degrees Fahrenheit, 200 degrees Celsius, and enormous pressure, hundreds of tons, the wood particles and resin fuse together. The mat is compressed down to the thickness of a board, usually between half an inch to an inch thick. This pressing process doesn't just flatten the fibers, it actually transforms them, melting the resin and bonding everything into a single solid sheet. The heat sterilizes the board, while the pressure ensures uniform density. When the press opens, what was once a loose pile of waste fibers has become a rigid, durable particle board panel. Freshly pressed boards are still hot and flexible, so they move into a cooling system. Giant fans and conveyor lines gradually bring down the temperature, allowing the boards to harden fully. Once cooled, the boards are trimmed to precise sizes using high-speed saws. The rough edges are cut off, leaving clean, uniform panels. Next, the boards are sent through industrial sanding machines. Sanding smooths out the surface, making it ready for laminates, veneers, or direct painting. At this stage, you'd be surprised how professional and finished the boards already look. What started as broken pallets and furniture is now a stack of sleek, standardized particle boards ready for use. Before shipping, every batch undergoes strict quality testing. Engineers check for density, ensuring the board is uniform, moisture resistance, simulating exposure to humid environments, strength, pressing and bending tests to mimic real-world use. Only boards that pass all these tests are packaged and sent to customers. So, where do these boards go? Particle boards are used in furniture, desks, wardrobes, cabinets, flooring, underlayment beneath carpets and tiles, construction, walls, partitions, shelving. They've become a backbone of affordable modern living, and all from waste that might have ended up in a landfill. And there you have it, the incredible journey of wood waste as it's transformed into durable particle board inside a supergiant recycling plant. If you enjoyed this behind-the-scenes look, don't forget to like, subscribe, and hit the bell. In the United States, millions of cars reach the end of their life every year. Some are the unlucky victims of highway accidents, twisted and mangled beyond recognition. Others simply grow old, engines worn, frames rusting, electronics failing, until repairs become more expensive than the vehicle is worth. But not all disappear into the shadows. In the heart of America's industrial landscape, there are places where endings are turned into beginnings. Today, we're taking you inside one of the most extreme processes in the automotive world. How old cars are stripped, crushed, and reborn as pure scrap metal. Before we dive in, make sure to hit that subscribe button and turn on the notification bell so you don't miss any of our upcoming videos on incredible industrial processes from around the globe. Trust me, today's journey from a beat-up car to a gleaming pile of scrap metal will blow your mind. Before the real destruction begins, the car is picked apart with surgical precision. Workers move quickly, armed with wrenches, power tools, and an intimate knowledge of automotive anatomy. Every piece that can be reused, resold, or repurposed is removed. The headlights are unbolted and set aside, destined for resale to a body shop. Side mirrors, door handles, and the steering wheel are removed. Small parts that can still command a decent price in the used parts market. Wheels and tires are pulled off, their rubber still worth something to a driver somewhere. The catalytic converter is always a priority. Containing small amounts of precious metals like platinum, palladium, and rhodium, it's one of the most valuable components in a modern car. Mechanics handle it with care, knowing it might be worth more than all the other parts combined. Seats, seat belts, dashboards, all come out if they're in good condition. Even the battery is lifted out and sent to a separate recycling line, where its lead and acid will be processed under strict safety protocols. To a casual observer, this dismantling might seem like unnecessary effort before the crushing begins. But for the scrapyard, it's a vital part of the business. Selling these components helps offset the costs of operation and ensures that usable resources are not destroyed prematurely. Once stripped of its valuable parts, the car is drained of the liquids that once kept it alive. The process is methodical. A suction pump draws out the engine oil, thick and blackened from years of use. Coolant is siphoned from the radiator, its once bright green now faded to a dull, murky hue. Transmission fluid, brake fluid, and power steering fluid all flow into separate containers. Gasoline still left in the tank is carefully pumped out and stored for reuse. Even a nearly empty tank can yield a gallon or two, enough to be worth saving. This step is more than a matter of thrift. Left inside the car, these liquids would leak out during crushing or shredding, contaminating the soil and water supply. Oil can cling to soil particles for decades, and even a small amount of coolant can be deadly to wildlife. By draining every drop, scrapyards not only meet environmental regulations, but also fulfill an unspoken responsibility to protect the land around them. Now the car stands empty, hollowed out and dry. This is when the true spectacle begins. The crusher, a machine as tall as a two-story house and weighing tens of thousands of pounds, looms over the stripped carcass. It's a simple design in principle, a massive hydraulic press with the power to flatten steel like paper.